So should have your test for you Thursday. Don't have them today yet. I'm sorry. It usually takes me. It's usually a week after we take it when I get it back to you. So, should have those Thursday. As soon as I get them finished, I'll put the grades on Canvas. So you'll be able to see the grade as soon as I get them finished. Okay. Nope. Yep. We had break for the tests. So, yeah. Yeah. So our next assignment will be due Tuesday. Yep. Okay. Missing anything we need to talk about other than math? Okay. All right. So we are moving into stuff for test 2. In test 2, we will talk about functions, mainly, is our main topic. So we have some sections out of chapter 2 and chapter 3. Just a little bit out of chapter 3. It's just the first 2 sections out of it. This section, I'm kind of pulling topics from, some of it's from the preliminary chapter, some of it's from the section on actual linear equations, and I'm kind of pulling stuff from several places, so it doesn't really match up exactly with one of the sections in the book, so I just gave it the name linear equations and graphs, and that's what the assignment's called too. So let's see. Oh, so in here, masks are optional. You can probably guess because I'm not wearing one, but so supposed to be up to the teacher in each room. So if anybody's uncomfortable and wants like a little section for mask people, we can do that. Just come let me know. But other than that, it's just wear one if you want to. Don't wear one if you don't want to. Okay? But don't let your guard down too much, okay, because I am having some students email me that they're positive for flu. So get to add that to the fun. So don't be letting people cough on you and stuff. Okay? All right, so we're going to start with the very basics as far as the coordinate plane, and then we're going to build our way up from that and look at some linear equations today. Okay? So if we have a grid like this, we can call our horizontal axis here, our main one, the x-axis. And then we could call our vertical axis there the y-axis. And then what's going on when we have a grid system laid out like this is we're kind of, the whole thing we call the plane, and if we're just thinking about some flat surface, we call that the plane. Since we're putting coordinates on it, you can call it the coordinate plane. So when we split it up like that, we actually end up with 4 pieces to the plane. Okay, so we do have this point where the x and y axis crosses. Okay. And as far as our numbering system we use, we call that the point 0, 0. Because each point in the plane we give an x coordinate and a y coordinate, and that tells us which way to move starting at this point 0, 0. Anybody remember what the name of that is? The origin. Yes, the origin. Okay. So we'll have 2 numbers. Sometimes we call them an ordered pair because we have 2 of them. And they are in order because we do x first and then y. So when we see the x coordinate, we'll talk about how far we should move left and right starting at the origin. And then the y coordinate tells us how far we should go up or down starting at the origin. Okay. So for the x-axis, we have positive numbers going to the right and negative numbers going to the left. It's just like our normal number line. Okay. For the y-axis, positive means up, negative means down. Okay. with that, we can get back to what I was saying before. Our coordinate system splits the plane up into 4 pieces. Okay, since we have 4 of those, we call those our 4 quadrants. Okay. And we give each one of those a number. Okay. So we start with this one, and we use Roman numerals. Okay. There, that green's not showing up real great, is it? We call this quadrant 1, Roman numeral 1. Okay, and then we go counterclockwise. So we'll call this one quadrant 2. This one's quadrant 3. And then this one's quadrant 4, so in Roman numerals that's IV. Okay. So if we have a positive x coordinate and a positive y coordinate, so maybe we're going to go start at the origin, right, and we'll go to the right 3 and up 2. That would give us this point, the point 3, 2. Since our x and our y coordinate are positive, we would know that we're in quadrant 1. Okay, quadrant 1, we're always going to have positive x and positive y. Okay. If we want to end up in quadrant 2, okay, so we start at the origin, maybe we'll go to the left 2 and then up 4. So we would get there. So left 2 would be negative 2, and then up 4 would be positive 4. Okay. We get to this point there. Okay. So in quadrant 2, we're going to have, I'm going to do that in blue, and then we're going to have negative x and positive y. Okay. Quadrant 3, we're also going to have negative x, but we'll have negative y with that. So let's see, maybe like negative 1, negative 2. Okay. And then quadrant 4 is kind of the weird one. For some reason, we just really don't end up spending a whole lot of time in quadrant 4, not as much. But in quadrant 4, we'll have positive x and negative y. So let's see, 1, 2, 3, 4, 5. I'll go over 6 to the right and then down 2. So there's a point 6, negative 2 in quadrant 4. So here we have positive x, negative y. So not a lot there. It's just the basics. Just the basics. So these coordinates that we're using, there are different coordinate systems that you could use. Using a grid like this, one name for that is we call these rectangular coordinates. Okay. Or maybe a little bit fancier name would be to call these Cartesian coordinates. Calling them Cartesian comes from, I know there's some accent mark I'm missing in there for Rene Descartes, but French philosopher, mathematician. You get Cartesian from his last name there. Okay. So that's what we'll be working in. There are other systems. You can do polar coordinates where instead of a grid you have circles. And then if you go in 3D, you can have spherical coordinates where you're using spheres instead. We're all going to deal with rectangular in here. Okay. That's where we're at. So the main thing to take away from this, okay, we want to be able to plot points. So you want to know where like the point 7, 2 would be. Right? So that's positive 7, so you go to the right 7. and then positive 2, so we go up 2. Okay? And we have the plot points. And then you want to be able to identify which quadrant a point is in. 1, 2, 3, or 4, so remember those. Any questions on any of that so far? Stuff you've seen probably, maybe it's been a while. Okay. All right, so our main goal in this section, we did want to get some of that basic refresher anyway. Our main goal, we want to talk about the graphs of lines in this section. So we have something like this. I've got my ruler, so maybe I can actually draw a straight line. Okay. Here's the graph of a line. Okay. What we want to be able to do, we want to be able to describe this line. We want to be able to talk about, the first thing we're going to talk about is slope. Okay. Then we also want to be able to describe the intercepts. So we'll remind or learn what those are. Okay, so those are the two main properties that a straight line has. It has a slope, and then it has intercepts, maybe only one intercept. Okay. So let's talk about slope first. Okay. We'll come back to that graph. We've got 4 basic categories or types of slope that a straight line can have. Okay. So slope, one way we talk about that sometimes is we talk about rise over run. So how much does our graph move up and down versus how much it moves left or right, rise over run. Okay. So we've got, let me switch colors here. We've got 4 basic types. So we could have one that goes up and to the right. Like we're moving from the left to right, we're thinking about what happens to our graph. So it goes up from left to right. Okay. We would say this line has positive slope. Okay. If we have one that goes down from left to right, we'd say that line has negative slope. Okay. And then we got 2 more that are a little bit more weird. Okay. If you just randomly have a line in a plane, you just randomly pick some line, it'll usually be one of these 2, either have positive or negative slope, but we do have 2 special cases. And if we have a horizontal line that's perfectly flat, if we have that situation and we're thinking about it as we move from left to right, are we going up or are we going down? Neither one, right? It's not changing as we move from left to right. You may know what kind of slope that line will have. Not yet. Horizontal line has, we said it doesn't change as we move from left to right, so no change. What number would be nothing? 0. I have 0 slope. So I could say we have 0 slope, or a slope of 0. Okay. And then our other weird one is if we have a line that's perfectly vertical. Anybody remember what that one is? Somebody said it last time, I think, on the 0. Undefined. Yeah, we say if we have a vertical line, let's say the slope is undefined. Okay. So our issue there, we're thinking how much does our graph change up and down versus how much it changes left and right. Well, it doesn't change any left or right. And then if we think about how much it changes up and down, it goes forever. So it gives us an issue with talking about like a ratio of those two things there. So maybe you could think about it as being like infinite slope. Okay. There are some problems with that. So we just end up saying it's undefined. Okay. So any straight line is going to have either positive slope, negative slope, zero slope, or undefined slope. Okay. So let's talk about how to calculate that. Okay. So we have a slope formula. And our slope formula says m, which is the symbol we use for slope. I tried to look up the history on why we use m for slope, and there's not a lot of real good evidence how it got started. Some people say it comes from like the German word for mountain or something like that. Was not real agreed upon, so I don't have a good answer for you why we use m for slope. Okay. That's what we have. So if we want to calculate slope, okay, what we're trying to figure out is how much does our graph change vertically compared to how much it changes horizontally. So what we do is we take the y coordinates of two different points on the graph. We see how far apart they are. And then we divide that by the x coordinates of those same 2 points on our graph. Subtracted, we can see how far apart those are. Okay. So the top's like how far apart are our y coordinates, the bottom's how far apart are our x coordinates, and we get that ratio, we get that fraction. Okay. So here we would have 2 points on our graph, x1, y1, and x2, y2. And they need to be 2 different points. Because if they're the same point, we can't find slope using this formula. Because if y2 and y1 are the same, that's no big deal. Right, we just get 0 on the top. But if x2 and x1 are the same, we'll get 0 on the bottom, and then we can't divide. We can't divide by 0. So we need to pick 2 different points. And then when we do that, we can take those coordinates and find our slope. Okay. So let's go back to that line I drew earlier. Okay. Let's calculate the slope. So we need to pick 2 points on our graph to be able to find the slope. If we're having to pick them off the graph instead of just being told that they're on the line, we need to find where it crosses the coordinates at exactly some number. Okay, so here's one point I've got drawn in. So this first point right here on the y-axis, what's its coordinates going to be? Yeah, so we haven't gone any to the left or to the right. So our x coordinate is 0. But then we've gone 2 units up from the origin, so that's 0, 2. And now I'll write it over here so we can see it better. Okay. And then for the other point I've got drawn in here, we went 1, 2, 3, 4, 5 to the right. So our x coordinate is 5. And then we went up 1, 2, 3. So y coordinate's 3. Okay. And then here's our formula again. Okay. So it's a good habit. You don't have to do this, but it's a good habit to label your points, because what we don't want to do when we're plugging into the formula, it doesn't matter which one you call point 1 and which one you call point 2. But what we don't want to do is we don't want to change our mind in the middle of the problem. We'll end up getting the wrong numbers in the wrong spots. So it's a good habit to label these. So that's x1, y1. This one's x2, y2. If you want to switch them and call the first one x2, y2 and the second one x1, y1, that's fine. We just need to commit to one of them being point 1, one of them being point 2. Then if we plug into our formula, so that's y2, so that was 3, minus y1, which is 2, over x2, which was 5, minus x1, which was 0. And 3 minus 2 is 1. 5 minus 0 is 5. So our slope of this line would be 1 over 5. 1 over 5. And what's that slope telling us? That slope is telling us if we start at some point on the graph, it doesn't matter what point we start at. I'm going to start over here this time because that wasn't one of our points we used. It says if we go up 1, because it's a positive 1 on the top, right? So go up 1 unit, and then we've got a positive 5 on the bottom, that's our run, and go over 5, we're going to end up at another point on the graph. Okay? And we did the same thing here, right? Up 1 over 1, 2, 3, 4, 5. And it doesn't fit on the graph, but we could do it again. Up 1 over 1, 2, 3, 4, 5. It would be somewhere in there. Okay? And we can even switch the signs as long as we switch both signs and go backward. Right, we could go down 1 and to the left 5. Get on there again too. See? Right, so that's our slope. Slope says every time we go up 1 unit, we've got to go over 5 units to stay on our graph. And it's positive. We could kind of tell that already from our picture, right? Because it's rising from left to right. So positive slope. Okay. All right, let's find another slope here. Sometimes you do have to be a little more careful with the signs. So there's another slope for us to find. Doesn't matter which point we call. Here's our formula. Doesn't matter which point we call point 1, which one we call point 2. We just got to make a commitment. Can't change our mind in the middle of the problem. So call that x1, y1. This one x2, y2. So finding my slope here, y2 is negative 1. And it's always going to be minus. But then our y1 is negative 6, so I got to subtract a negative 6. Then I've got x2, which is 8, minus x1, which is 6. So you have to watch out for getting double minus signs in there. If you get the double negative signs, you can change it to plus. That's what you want to do. So that's the same thing as negative 1 plus 6. What do we get there? Negative 1 plus 6 is 5. 8 minus 6 is 2. So there's our slope this time, 5 over 2. Yep. Yep. Yeah, minus and negative means the same thing as plus. Yep. Okay. What questions on that one? So that's finding slope. Finding slope. Okay. Okay, so if we just have 2 points, that's how we find it, or we kind of did it without talking about it. If you've got a graph, and you can see where some of the points line up, you can just count off the graph. You don't have to do the formula. Like if I knew these 2 points were on my graph, I could say, well, I've got to go up 1 and over 1, 2, 3, 4, 5. So 1 over 5 would be okay there. And if you accidentally miss one, like if I start here and I don't see that point's on the graph, so I think I've got to go up 2, then I'd have to go over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 2 over 10 simplifies to 1 over 5. So you're okay. As long as you started a point on the graph and ended a point on the graph, you're going to get the right answer. Okay. All right. Questions there? All right, so that's one of the big properties of a line, is its slope. Okay. The other thing we want to talk about, one other thing, is if we have a line that crosses the y-axis or the x-axis, okay, the place where it crosses the y-axis we call the y-intercept. Okay. So if you intercept something, that means it meets up. You and it meet up, right? Okay. And then the place where our graph, if we have one, the place where our graph crosses the x-axis, we call the x-intercept. Okay. So not every line has both of these, because what if we have like a vertical line, then it only has one. Which one does it have, x or y-intercept? It's only going to have an x-intercept, right? It's not going to cross the y-axis because it's vertical. Or if we have a horizontal line, it's only going to have which one? Y-intercept. Yeah, it's only going to have a y-intercept and not an x. Okay. Any other line, other than a vertical or horizontal line, will have both. Okay. There's one other weird thing that can happen though, and that is if we have a line that goes right through the origin, it crosses both axes at the same point. So the x-intercept and the y-intercept are at the same spot, and it's at the point 0, 0. So that is a little weird. That can happen. So this y-intercept, we're going to give a symbol to. It's going to get called b, lowercase b. So then that leads us to one way we can write down the equation of a line. If we know the slope of a line and we know its y-intercept, we can write down an equation. So that's one way. So this is called the slope-intercept form of a line. And usually people will remember this one. It sticks with people for some reason. So we'll have y equals what? Mx plus b. That's right. Mx plus b. Okay. So again, m is our slope. And then b is our y-intercept. So really B is, the y-intercept is actually a point, so you would need an x comma y to talk about where it's at. So B is really the y coordinate of our y-intercept. So if you know those two things, you just plug in for M, you plug in for B, you get the equation of that line. So let's go back to our line we found the slope for. So here it is. What's the y-intercept on that one? Or is it across the y-axis? At 2, yeah. So you could say the point 0, 2, or the y-intercept's 2. Okay. So here this is like, well, that's like our B. So if we wanted to write down the equation of this line, we could say y equals the slope, which we already figured out was 1 over 5, times x. And then we're crossing at positive 2 on the y-axis, so plus 2. So that's the equation for that line in slope-intercept form. Questions on plugging in there? That's usually people like y-intercept form because it's pretty nice to work with. Just got 2 numbers to worry about. Okay. What if we needed to go the other way? What if we had an equation in y-intercept form, slope-intercept form, and we needed to do the graph? So there's an equation here. What's our slope going to be? Negative 1 over 3. And then our y-intercept, what's it going to be? Negative 1. Negative 1. Okay. So to put that on our graph, our y-intercept is at negative 1. So I'm going to go over here, start at the origin, go down 1. So there's my y-intercept at negative 1. And then I can use my slope to figure out another point on the graph. And so my slope was negative 1 over 3. And let me write it over here again. We can keep track. Negative 1 over 3 was my slope. So negative 1 means if I start at this point and I go down 1, and then which way 3? To the right 3, right? Because positive to the right. So if I go down 1 and to the right 3, so down 1 to the right 3, that should be another point on the line. If I want to, I can do it again. I can go down 1 and to the right 3 again. Get another point. And if you have an issue where it's not fitting on your graph or something and you want a point on the left side, you just switch both of the signs. So negative 1 over 3 is the same thing as 1 over negative 3. So we could go up 1 and to the left 3. That's going to be on the line also. So we only need 2 points, but it's good to do some extras sometimes in case you make a mistake on one, you'll see it doesn't fit in. So I want to draw our graph. There's our blue line there. Questions on that one? Counting the slope. Go back over so you can see the, yeah. Go. Okay. So that's one way we can work with the equation of a line is in the slope-intercept form where, so if you have it in the form where it's y equals and everything's simplified, that's slope-intercept form. In order to come up with the equation of a line, we got to know the slope and the y-intercept to use that form. Okay. We're not always quite that lucky. Okay. Sometimes we don't know the slope and the y-intercept. Sometimes we just know the slope and then some random point that's on the line. Okay. It might not be the y-intercept. We can still come up with an equation for the line then. We just can't use y equals mx plus b. We have to use a different format for our equation. So we need to take a look at that form of our equation too. So in the situation where we just know some point, it might not be the y-intercept, and we know the slope, we get this thing we call the point slope form. And it looks like this. We do y minus y1. That equals m times, with a parenthesis, x minus x1. Okay. And the point x1, y1 is just some point on the line. And then m is still the slope, just like it was before. Okay. So really, let me change colors on these, because these blue ones are the places where we plug in numbers. The y and the x, just the regular y and the regular x, they're going to stay in there. Because with the equation of a line, we've got y and we've got x. Okay. So then x1, y1. Okay. We plug in. Okay. So let's do one with this. Let's see. Find us a good example here. Maybe. Okay. Let's see. I want to find the equation of the line. Through the point. -1, -2 with the slope -5. So might not be quite as vital. On these, it still can be helpful for you to label the things that we're plugging in. Okay. So in our point slope form, x1, y1 will be the x coordinate and the y coordinate of our point. The slope's going to be m. Okay. So we'll have y minus y1, the y coordinate of our point, which on this one is -2, and equals our slope, -5, times x minus the x coordinate of our point, which is -1. They're not always negative on the point, right? It just happened they were both negative on this one, so have to be careful with those double minus signs. Okay. Webassine would take this as our equation of the line, actually. Sometimes it's nice to solve it for y, because then we can tell what the y-intercept is. And maybe it makes it a little bit easier to graph, or something like that. So if we wanted to solve it for y, I'll get rid of my double minus signs. And then we've got to distribute our slope. So that's negative 5x minus 5. And then one more step, we can subtract 2 from both sides. So negative 5x minus 7 would be our equation in slope-intercept form. Okay. So where would our y-intercept be? Negative 7. We can figure that out without even having to make the graph. Okay. And while we're here, we might as well graph this thing. Okay. So let's graph it. A couple ways we could go about this, because we kind of have some extra information on this one. One thing we know, since we solved it for y, is we know the y-intercept's negative 7. So let's see if I've even got room for that. 1, 2, 3, 4, 5, 6. Yes, right at the bottom. Okay. On mine. So, but let's say maybe that didn't fit. Maybe I only had a 6 by 6 grid. Okay. Something else we could do is that we already know something else, right? We know the point negative 1, negative 2 is on our graph. So we can plot that one as well. Okay, so negative 1, negative 2, right there. Okay. That's really enough for us to draw our graph, but let's just review a little bit here. What's our slope? Negative 5, or we could write that negative 5 over 1. That means we can go down 5 and to the right 1. Since we're down at the bottom of our graph, we really don't have any room to do that, so we could switch the signs, right? We could go up 5 and to the left 1. That's the same thing. So we go up 1, 2, 3, 4, 5 to the left 1. Get another point on there. Okay. And then if we draw in our graph, something like that. Okay. Here's our line. And it falls from left to right, negative slope. Okay. Questions on that one? We don't have too much more to do this section. We don't have too much more to do. Okay, so no more formulas or anything right now, but let's look at a different type of problem. Okay? We could have one that says this. So another one, find the equation of the line through, this time it's going to give us 2 points. So let's see. We're trying to come up with the equation of a line. We've got the 2 points, but what vital piece of information are we missing? The slope. So what can we do about that? We've got 2 points. So we can find the slope. Yeah, we can find the slope. Okay. Okay, so slope y2 minus y1 over x2 minus x1. So let's see, that's negative 2 minus 3 over negative 1 minus negative 2. On the top, that's negative 5. On the bottom, the same thing as negative 1 plus 2. So end up with negative 5 over 1 again. Okay, that's coincidence there. I think maybe I picked the same line as the last one. I don't know. Okay. And then what? We've got the slope now. We've got a point. So we can use a point slope form, right? I think this one, I think I did accidentally pick the same line twice. So let's look at it. So we do y minus. Which point do we use when we do point slope form? Doesn't matter. Pick whichever one looks easier. Okay? I'm just going to go with the one I've already got labeled x1, y1. You'll get the same thing either way. So I'm going to do y minus 3 equals my slope, negative 5. X minus negative 2. Okay. So that's acceptable for WebAssign there. Or we can solve it for y. And yeah, we do. It's the same. Ended up being the same line as last time. I accidentally picked the same one twice. Yeah. So first, change this to plus 2, and then distributed the negative 5, makes it negative 10, and then I add 3 to both sides. Yeah, add 3 to both. Okay. Questions on that one? Hanging in there best you can. Trying. Okay. So a bunch of you probably remember most of this. I know it's not real exciting. Okay. So one other topic. Okay, one other topic. We've got two special relations between lines that we want to talk about. Okay, so if we have two lines that never touch each other, you remember what we call those lines? Parallel, good. Yeah, parallel. Okay. Or if we have two lines that meet at 90 degrees, remember what we call those? Perpendicular. Perpendicular lines. So the main thing we want to talk about here is we have parallel lines or if we have perpendicular lines, what's the relationship between the slopes of those lines? So if we have parallel lines, they're both going the same direction, okay? And they're going exactly the same direction, right? Because they never cross, they never intersect. So since they're going exactly the same direction, every time one goes up and over a certain amount, the other one does too. What's the relationship between their slopes have to be? They're the same. They have the same slope. Okay, so if you have two lines that are parallel, you know that they have to have the same slope. Okay. Perpendicular lines is a little bit harder to think your way through. one part of it we can pick out pretty easy. So like here, this line has a positive slope. What's the sign of the other slope going to be? Got to be negative. All right. So one part of the relationship between the slopes of perpendicular lines is that they have opposite signs. Okay. The other aspect is a little bit trickier to think your way through. Okay. But these slopes are also what we would call reciprocals, right? Well, they're flipped. So let's say perpendicular lines have opposite reciprocal slopes. Okay. So for parallel lines, maybe the slope of line 1 would be like 1/3. Then the slope of line 2, what's it have to be? 1/3. They got to be the same. Okay. Over here with perpendicular lines, if the slope of line 1 was like 2/5, and the slope of line 2, what do we have to do? We have to change the sign, so we got to make it negative, and then flip it. We got to do the reciprocal, so we would have 5/2. So we got to flip it and change the sign for perpendicular lines. Okay. So how that's going to come into play is going to be like, here's the equation of a line, find the parallel line that goes through a certain point. So since it says it's parallel to the line it gives you, you got to use the same slope. Okay? And then whatever point they give you. Okay. We're not going to get too crazy with it. Maybe you want to know the relationship of the slopes, though. Okay. Okay. So, last thing I think here, let's see. Let me double check, make sure I got you covered. Yeah. The last thing here, let me just show you how to graph a line in WebAssign. Okay. It's not too tough, but I just want to make it a little easier on you showing you. You've only got a couple where you have to put the graph in. Let's look at this one. Okay. So this one we've got 5/3 x minus 2 is the equation of the line. So what would our slope be on that? Be 5/3. Right? The part in front of the x is our m. And then our y-intercept, be a little careful because it wants you to put it in as a point. So our equation says minus 2. So the y-coordinate is going to be minus 2. So what we would put in on WebAssign, it already has the parentheses for the point. So we would just put in 0, minus 2. Would be all we have to put in there. Okay. So then for drawing our graph, and we'll go to the line button, and it's going to pop up some choices. We want arrows on both ends of all of ours, so you just click that button again. Okay. And you just click one point, the first point that's on the graph. So I know 0, -2 is on my graph, so I'm going to click that first if I can. I forgot WebAssign doesn't like touchscreen, so you would click 0, -2 first. Okay. And then how could we get another point? Up 5 over 3, so we'll go up 5, 1, 2, 3, 4, 5, over 3, 1, 2, 3. Click there, and it's going to draw the line in for you. I just forgot to bring my mouse today. So click the first point, count over to your next point, click it, and the line will pop up. Okay, line will pop up. It's not bad. Okay. All right, if you have any questions or anything, feel free to hang around. Sign-in sheet's up here if you need it. Okay.